Hello there and welcome to the June 2018 paper. Here we're looking at question 3. So part 3a asks us to shade on an Argand diagram the set of points defined by these two things here. So let's draw ourselves a set of axes first. Let's have a look at the first one. The first one is, yes, it's the set of complex numbers, but this is the key bit for the first locus of points that we're going to draw. It's the modulus of z minus 1 minus I is less than or equal to 3. So this question here is going to be centered around the point 1 plus I, and it's going to have a radius of 3. So it's going to come round like that. And then part 2 is going to be this bit here, where we have a argument of z minus 2. So it's going to start this point at 2. And it's going to have an argument in between pi by 4, that's exactly diagonal up to the right, and 3 pi by 4, that's exactly up to the left. So diagonally up to the left. And it's exactly going to go through the point 1 plus I, because it's going 1 across, 1 up, so it will hit this coordinate of 1 plus I. And it's the intersection of these two, so the first one is inside the circle, the second definition of the locus is in between the two arguments, so it's going to be this section here that defines the intersection of both those sections, both those locus of points. So that's the answer to part A, that's worth 5 marks. Let's now move on to part B. The complex number W satisfies w minus 1 minus I equals 3, and the argument of w minus 2 equals pi by 4. So that's this line here. So how are we going to find in simplest form the exact value of the modulus of w squared? I think what I'll do is I'll have a look at this bit here first, because if it's on this line, then effectively what we're trying, and it's on this circle, we're effectively trying to find this point here. Now, this line, you could actually give it the equation y equals x minus 2, because it's exactly a diagonal up to the right, right by 1, up by 1, and it's going to, if you track it backwards down to here, it's going to have an intersection of minus 2 on this axis here. So you could say that the intersection on this line here is going to be along this line here of y equals x minus 2. And the circle is going to have an equation of x minus 1 squared plus y minus 1 squared equals, now the radius is 3, so therefore it's 9 on the other side. So what I've done here is I've turned the equations of these locus of points into Cartesian equations, like I have here. Now I need to solve these by simultaneous equations. So I'm going to substitute y into this part of the equation here. So it's going to be x minus 1 squared plus x minus 3 squared equals 9. So therefore it's going to be x squared minus 2x plus 1 plus x squared minus 6x plus 9 equals 9. I'm going to cancel out the 9 on both sides and just put a 0 there, tidy that up quickly. So simplify this, it'll be 2x squared minus 8x plus 1 equals 0. Now solve this in your equation solver, and you're going to get, let's just type it in. If you type it in, you're going to get x equals 2 plus root 14 over 2. Now you'll actually get a second answer, but what that second answer is referring to is it's referring to this point down here. Now when I created this line of y equals x minus 2, it will actually give us the equation of the whole line. But actually what I was looking to define is just the half line between, from 2 and then diagonally up to the right with the argument of pi by 4. So it's just this point here. The higher of the two x values, you can ignore this solution down here. So yes, you're going to get a second x value, but that's referring to this intersection here. So therefore, so this can be ignored. And if x is equal to this and y is equal to this value minus 2, then y is going to equal root 14 over 2. Now I need to link it back to this question here. Find in the simplest form the exact value of the modulus of w squared. Now the work I've done so far in this question has effectively defined w to be x plus yi. You can define it as a plus bi if you wish to, but x plus yi is what I've done here basically. So if I want to now work out the modulus of w, that's going to be the modulus of 2 plus root 14 I over 2. Sorry, no, it's not I, is it? It's just 2 plus root 14, and then it's plus y will be the I one, root 14 over 2i. So now, if I work out what that modulus is, it's going to be the real part squared, so 2 plus root 14 over 2 squared, plus root 14 over 2 squared, all square rooted. That will equal the square root of, if I simplify all of these stuff inside the bracket, I get 11 plus 2 root 14. If I simplify all of that, so therefore the modulus of w squared is just going to be this value squared, so get rid of the square root, 11 plus 2 root 14. Tough question, that one. I'm really surprised they've only given you 4 marks for that question there. But there we are. That is the answer to this question. 11 plus 2 root 14. And there we are. That's the answer for question 3. That's 9 marks in total there. Let's move on to question 4.